Hello all, welcome to the Counting Well RMS Prep live session. We know that the baseline for RMS, that is Ramanujan Math Scholarship, is already released and we have the final assessment test on 30th April. How to participate? You just have to complete the course in step 1 of the RMS in order to qualify and take the scholarship. The course is designed to help you fill any learning gap from previous academic year and get you prepared for the new class. So we are here to help you qualify the scholarship. For this, stay tuned to the session and get ready for the test. In this session, I will take you through the chapters. Angles and triangles, polygons and circles. Let us look at the chapter angles and triangles. To determine whether the given two lines are parallel using the condition on angles made by their transversal, we can check by the following conditions. So let us see those conditions. Check whether the pair of corresponding angles are equal or not. If the pairs of corresponding angles are equal, then the lines are parallel. Check whether the pairs of alternate interior angles are equal or not. If the pairs of alternate interior angles are equal, then the lines must be parallel. Check whether the pairs of interior angles on the same side of the transversal are supplementary or not. If the pairs of interior angles on the same side of the transversal are supplementary, then the lines must be parallel. So these are the three conditions we can check for parallel lines. So let me highlight. So we have to check for corresponding angles and they should be equal. Then alternate interior angles, they should be equal. Interior angles on the same side of transversal should be supplementary for the lines to be parallel. So let us look at this problem. Let us check if the two lines shown here, A and B, are parallel to each other or not. In this figure, we can see lines A and B are intersected by the transversal C. So you can see the angles given are 59 degrees and 93 degrees. Let us take the linear pair of 59 degree as X. So here we have the linear pair of 59 degrees as X. What we are going to do next? We must have 59 degree plus X degree is equal to 180 degrees. That is, as they are linear pair of angles, what will be their sum? Their sum should be 180 degrees. So what is the value of X? Will subtract 180 degree minus 59 degrees. So we have 121 degrees. From the figure, what can we observe? 121 degrees and 93 degrees. So as you know, here we have found 121 degrees for the value of X. Now, X and 93 degrees are nothing but alternate interior angles and they must be equal if the lines are parallel. But 121 degrees is not equal to 93 degrees. Therefore, we can conclude that the lines A and B are not parallel. I hope this question is clear. Now let us see one more problem. We have to check whether the lines P and Q are parallel or not. The angles given are as shown here 78 degrees and 77 degrees. In this figure, lines P and Q are intersected by the transversal R. So here you can see transversal is R. What is a transversal? A transversal is nothing but a line which intersects two or more lines at two or more distinct points. For example, if a transversal intersects two lines, then it should intersect those two lines at two distinct points. So let us take a vertically opposite angle of 78 degrees as x. So here we have, just give me a second. So here we have 78 degrees and the vertically opposite angle to 78 degrees is x. Next, what we are going to do is, as we know vertically opposite angles are equal, so we have here 78 degrees and here we can see it is 77 degrees. Now from the figure we can see 78 degrees and 77 degrees are the pair of interior angles on the same side of transversal. So here you can see the transversal R and 77 and 78 are on the same side of the transversal, correct? These are on the same side of the transversal R. That's why they should be supplementary if the angles P and Q are parallel. But if you check 78 degree plus 77 degrees is 155 degrees, which is not equal to 180 degrees. Hence, P and Q are not parallel. This is what we can conclude. Let us find unknown angles using angle sum property. First of all, let us see what is angle sum property. Angle sum property of a triangle states that the sum of the measures of the three angles of a triangle is 180 degrees. For example, in triangle DEF, angle D plus angle E plus angle F is equal to 180 degrees. Let us solve one problem. Let us know how to find the unknown angle for the question below. We want to find the value of the unknown T in the given figure. Now what we are going to do, we are going to apply the angle sum property of triangle. We know that the sum of the measures of the three angles of a triangle is 180 degrees. So what we are going to do, we are going to add these three angles and take it equal to 180 degrees. So 45 degrees plus 53 degrees plus t is equal to 180 degrees. So this is nothing but 98 degrees plus t is equal to 180 degrees. So what is the value of t here? Value of t will be 180 degrees minus 98 degrees, which will be 82 degrees. Now let us see exterior angle property of a triangle. In the previous concept, we saw how to find unknown angle using angle sum property. So angle sum property is totally different from the exterior angle property of a triangle. It states that the exterior angle of a triangle is equal to sum of the opposite interior angles. So let me show you what is the exterior angle of triangle KLM. Here you can see we have a triangle KLM and KM is extended to the point N, correct? Or we can say we have a ray KN here. So KN is a ray which is extended part of the side KM of the triangle KLM. So exterior angle is nothing but here angle LMN. So angle LMN will be equal to the sum of the interior opposite angles. So if you take the exterior angle LMN, so you have to ignore this angle and take the opposite interior angles. So this angle and this angle. So you have angle KLM plus angle LKM is equal to the exterior angle LMN. So this was the statement of exterior angle property. Let us see how to verify this property. For this, we consider a triangle ABC with ACD as an exterior angle. So here you can see ABC is a triangle with ACD as an exterior angle. Through vertex C, this is the construction part. Through the vertex C, we draw a line segment CE parallel to the line segment AB. So this CE will be parallel to line AB. So this is by construction. Now in the given figure, what we have, AB is parallel to CE. This is by construction, and AC is the transversal. So let me show you where is AC. So AC is transversal. What can you say about the angles P and R? So here you can see the angles P and R. They are nothing but the alternate angles. So they should be equal because we have AB parallel to CE and AC as transversal. For parallel lines, or if we say if a transversal intersects two parallel lines, then the alternate angles formed are equal. That's why we have angle P is equal to angle R. Let us take this as equation 1. Now angle Q and angle S are corresponding angles. So here you can see angle Q and angle S are corresponding angles because we have AB parallel to CE by construction. So here we have AB parallel to CE, whereas BD is the transversal. So we have angle Q is equal to angle S. Let us mark this as equation 2. Now what we are going to do, we are going to add equations 1 and equation 2. So LHS to be added to the LHS of first equation to the second equation. RHS of first equation to be added to the RHS of the second equation. So we have angle P plus angle Q is equal to angle R plus angle S. What do you know? What is the angle R plus angle S? It is nothing but ACD. So angle ACD is equal to angle R plus angle S, but ACD is nothing but our exterior angle. So what do we get? We get that the exterior angle of a triangle is equal to the sum of its interior opposite angles. Let us move towards our next topic, which is congruent lines and congruent angles. What can you say about congruency of two line segments? Yes, it's very simple. Two line segments, if they have the same length or equal length, then we say it is congruent. Or if we have two line segments congruent, then we can say they have the same length or the equal length. Let us see the congruency of two angles. If two angles have the same measure, they are congruent. Whereas if we have two angles as congruent, then we can say their measures are also same or their measures are also equal. Now let us apply the knowledge of congruent lines and angles. Let us see whether the given line segments on the screen are congruent or not. What do you observe from the figure? We have line segments AB and CD have the same length. Hence, they are congruent. Let us see one problem where we are going to apply the congruency of lines and angles. In the figure, we have AB is parallel to CD. Let us identify the angle congruent to ABO. So, which is the angle ABO? Here we have angle ABO. From the figure, what we have, ABO is equal to 60 degrees and OAB is equal to 30 degrees. Correct? So here you can see OAB is equal to 30 degrees and ABO is equal to 60 degrees. What we can see, AB is parallel to CD, AB is parallel to CD, and the pair of alternate interior angles are equal. That's why we have OCD is equal to ABO. That's why OCD is equal to 60 degrees. So we have OCD is equal to 60 degrees. Then we have OAB is equal to CDO. That's why we have CDO is equal to 30 degrees. We know that the two angles of the same measures are congruent. So what we found, angle ABO is equal to angle OCD is equal to 60 degrees. Therefore, angle ABO is congruent to angle OCD. Hence, we have applied the knowledge of congruency of angles here and identified the angle congruent to angle ABO, which is angle OCD. Now, let us understand what are the different elements which make two triangles congruent. If the two triangles are congruent, all their corresponding parts are equal in measure. And if all the corresponding parts of two triangles are equal, then the triangles are congruent. So these are the two important statements regarding two triangles being congruent or the corresponding parts of two congruent triangles equal in measure. Consider the triangles MNO and PQR. So let us check how we are superimposing triangle PQR on MNO. We can see the corresponding vertices are M and P, NN, R, and M and Q. So we can see the vertices that match one another are M and P, N and Q, and O and R. So the matching vertices are nothing but the corresponding vertices. Let us see for the sides. The sides which match one another are MN and PQ. Then we have matching NOQR and OM and RP. The matching sides here are nothing but the corresponding sides. Let us see what are the matching angles. Matching angles are called corresponding angles. So here the matching angles are angle M and angle P, angle N and angle Q, angle O and angle R. Now we say the triangles MNO and triangle PQR are congruent if the corresponding angles are equal and corresponding sides are also equal. So angle A should be equal to angle P, angle B will be equal to angle Q, angle C is equal to angle R, and corresponding sides should also be equal. So the parts of the congruent triangles that match are called the corresponding parts. If you slide, flip, or turn a triangle, the size and shape of the two triangles do not change. Hence, the congruence is always preserved. For example, in the figure, ABC is congruent to triangle DEF. This means angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Sides AB is equal to DE, BC is equal to EF, AC is equal to DF. Now, Let us recognize corresponding parts of congruent triangles. Triangle ABC and triangle PQR are congruent under the correspondence ABC corresponds to PQR. This means vertex A corresponds to vertex B, vertex B corresponds to vertex Q, vertex C corresponds to vertex R. We have to write the parts of triangle ABC that corresponds to the side PQ, angle Q and side PR. Now, we know that when the triangles are congruent, their corresponding parts are equal. What is the given correspondence given? ABC is corresponding to PQR. This means A corresponds to P, vertex B corresponds to Q, vertex C corresponds to vertex R. So the corresponding parts are PQ side corresponds to AB, angle Q corresponds to angle B, side PR corresponds to side AC. So this is our solution. Let us start with the chapter polygons and circles. So what are polygons? They are nothing but closed plane figures made up of only line segments. And we can see polygons are classified based on the number of sides. If there are 3 sides in a polygon, we call it as a triangle. The prefix tri stands for 3. Similarly, if the polygon has 4 sides, it is known as quadrilateral. The prefix quadri stands for 4. If the quadrilateral has 5 sides, if a polygon has 5 sides, then it is called as pentagon. So here you can see the highlighted shape shows pentagon. Then we have polygon having 6 sides called hexagon. If it is having 7 sides, we have heptagon. For 8 sides, we have octagon. For 9 sides, we have nonagon. For 10 sides, we have decagon. What are parallelograms? So first of all, parallelogram is a quadrilateral, means a closed shape having 4 sides. And there are some properties which are satisfied by parallelograms. First is the opposite sides must be parallel and equal. So here you can see AB should be equal to CD, AD should be equal to BC, and AB should be equal to CD and BC should be equal to AD. AB should be parallel to CD and AD should be parallel to BC. Pair of opposite angles should be equal. So angle D should be equal to angle B. Angle A should be equal to angle C. Pair of adjacent angles should be supplementary. This means angle D plus angle C should be 180, or angle A plus angle D should be 180 degrees. Or we can take angle A plus angle B should be equal to 180 degrees, or angle B plus angle C is equal to 180 degrees. Then we have diagonals must bisect each other. So here you can see the diagonals AC and BD bisect each other at the point E. So we have AE is equal to EC, DE is equal to EB. So this is how we can summarize the properties of a parallelogram. Pair of opposite sides parallel and equal, opposite angles equal in measure, adjacent angles supplementary, diagonals bisecting each other means dividing each other into 2 equal halves. These are some of the quadrilaterals satisfying some conditions. First, we are having trapezium. It is nothing but a quadrilateral with one pair of opposite sides parallel. Here you can see these 2 sides are parallel to each other, whereas these 2 sides are not parallel. A rhombus is a quadrilateral with 4 equal sides. So here you can see these 4 sides are of equal length, but it is different from a square because here In spite of all sides of equal length, we have diagonals bisecting each other at right angles. We'll see more properties of rhombus in our further discussion. A square is a quadrilateral with all sides equal and each interior angle with 90 degrees. That was not in the case of rhombus. Then we have rectangle. It is a quadrilateral with each interior angle a right angle and opposite sides equal. So this side will be equal to this side and this side will be equal to this side. For a rectangle, we have length and breadth. So this is a chart which helps us to recall the properties of all the quadrilaterals. Here we have rectangles, square, parallelogram, rhombus, and trapezium. So in which of the following quadrilaterals we have all sides equal in the case of square and rhombus? Opposite sides are equal in case of rectangle, square, parallelogram, and rhombus. Opposite sides are parallel in all these quadrilaterals. All angles are equal in case of rectangle and square, each 90 degrees. All opposite angles are equal, but not in case of trapezium. Sum of two adjacent angles are equal except trapezium. The bisection of diagonals occur in all the quadrilaterals given here except trapezium. Then the bisection of diagonals is at 90 degrees for square and rhombus only. Let us consider one problem and identify the angles of the quadrilateral given. A quadrilateral has one pair of opposite sides parallel. The other pair of opposite sides are not parallel, but they are equal. Then we have to name the quadrilateral. You also have to find the angles of such a quadrilateral. Let us consider the step to identify which of the quadrilaterals have the given properties. So let us list down the property. One pair of opposite sides parallel, other pair not parallel but equal. So if two sides are equal, we have named it as isosceles, and since only one pair of opposite sides are parallel, it is nothing but a trapezium. Also, what can we say about the angles of such quadrilateral? Each pair of base angles are equal. After a circle, what is circle? It is nothing but the collection of all the points in a plane which are at a fixed distance from a fixed point in the plane. So that fixed point is nothing but the center. So if we have a fixed point and if we have collection of points which are at equal distance from this fixed point, that is the center, then we get a circle. How we can define circle in another way? It is nothing but a path of point in a plane such that it is always a fixed distance from the fixed point. So O is the center of the given circle. The fixed distance is nothing but the radius of the circle. So we can take AO or OB or OE as the radius of the circle. All the three have the same length. The line segment which joins 2 points on the circle is called a chord. So CD is a chord, AB is a chord. It should join 2 points on the circle. So you have A and B 2 points on the circle, C and D 2 points on the circle. If you join E and B also, it is also a chord because it is joining 2 points on the circle. What is diameter? Diameter is the longest chord. It should pass the center of the circle. So the only chord passing through the center of the circle is the line segment AB. That's why AB is the diameter of the circle. Now, what is circular region? A circle with its interior. So when I say a circle, it is nothing but the boundary part of the circle and we don't consider the inner region. But if we include the inner region also, then we call it as a circular region. Let us see what is a semicircle. It is nothing but half of the circle. So semi means half. The portion of a circle between the 2 points of the circle is known as the arc. So if you take any 2 points and portion of that circle, so here we can see the portion from P to Q. This is nothing but arc. The length of the complete circle is called the circumference, or we can say the boundary of the circle is called the circumference of the circle. Let us see what is a segment. It is nothing but the region enclosed between a chord and the arc. Here we have chord PQ and arc PQ, and the region obtained is nothing but the segment. So we have major segment and minor segment, as we have major arc and minor arc. So if the segment corresponds to major arc, we get the major segment. If it corresponds to the minor arc, then we get minor segment. Next, what is a sector? It is nothing but the region enclosed between an arc and two radii. So here you can see two radii are OP and OQ, and arc is PQ, and the region obtained is a sector. We have a minor sector and one major sector. So the one corresponding to the major arc is major sector, whereas the one corresponding to the minor arc is minor sector. If two arcs are equal, each arc is a semicircle and both segment and sector becomes the same. Each of them is called the semicircular region. So in which case do we have segment and sector coinciding? When the two arcs are equal. I hope this session was helpful. After RMS also, if you want to continue to use counting well to keep learning maths, practice and improve your score and develop good problem solving skills, then you can download the app from the App Store or Play Store. Also stay connected to our channel Counting Well and gear up. Complete the course at the earliest to qualify for the final scholarship test. Until then, keep learning and keep growing. Thank you. All the best for the RMS assessments.